ओके यस ठीक है. Jasmine, turn on your mic and video. Like it's not showing anything. 5, 6, 7. Start करें. Let's start है ना. So I'm sharing a screen. Just 1 second. Question visible? Mic on रख लो. If you want to ask anything, directly ask. Okay, so basically our first question is that an electron of mass me initially at rest move through a certain distance in a uniform electric field. हम लोग electrostatics शुरू कर रहे हैं and कुछ questions कर रहे हैं speed में है ना. So an electron of mass me initially at rest moves through a distance in a uniform electric field in time t1. A proton of mass mp also initially at rest takes time t2 to move through an equal distance in this uniform electric field. So let's say uniform electric field is E. So charge on proton or electron both is E, right? So E, that is force divided by mass. So I got acceleration, right? That is force divided by mass. So I got my acceleration. So acceleration for both is, so acceleration for electron is E by me, and acceleration for proton is E by mp. Only masses are different, everything else is same. So we need to find distance traveled is also equal. So I can write S is equal, both are initially at rest. So S is equal to ut plus half it squared. So half acceleration for electron and t1 square is equal to half acceleration for proton and t2 square, right? And they are asking what is t2 by t1. So t2 square by t1 square comes to be half cancel हो जाएगा, and it will be acceleration of electron divided by acceleration of proton और उसका square. So that is again acceleration is inversely proportional, so mass, so that will be mp by me और उसका square root will be answer. t2 by t1 will be square root of mp by me. So mp by me, so the answer is B. Any doubt? डाउट है तो जस्ट यस नो टिक कर सकते हो आप, और यू कैन जस्ट स्पीक. नेक्स्ट क्वेश्चन करें. ठीक है, लेट्स मूव टू नेक्स्ट क्वेश्चन. सो नेक्स्ट क्वेश्चन इज 1 सेकेंड. नेक्स्ट क्वेश्चन इज दिस. So here a parallel plate capacitor of area A and plate separation D, small d. So plate separation is given in this manner. That means current must be coming like this, right? Because that is the plate separation. So the capacitor are connected like this. Picture utna clear nahi, but the thing is ki they are having dielectric constant K1, K2 and K3 as shown in the figure. And if a single dielectric material is to be used to have same capacitance C, then that C in this capacitor, then the dielectric constant K is given by what? So here I am making the horizontal view. So basically they are splitted like this. So here we have K1, here we have K2 and here we have K3. So what I am saying ki let us consider each as capacitor. So C1, C2 and C3. So first this C1 and C2, they are in parallel, right? So this is like C1 and C2, and then they are connected with K3, that is C3. So that is capacitor C3 in series. Now overall capacitance पहले इन दोनों का C1 and C2 का calculate करो तो that will be C1 plus C2, and overall 1 by C is equal to 1 by C1 plus C2, that is like this capacitor plus 1 by C3. So let us just put value of each one in the equation. So what is 1 by C? C is epsilon naught A by D. K C equals to K epsilon naught A by D, right? So overall it is K epsilon naught A by D. Total distance is D, area is A, and equivalent k is k, so equals to 1 by, अब c1 plus c2 मैं यहाँ पे साइड में निकाल रहा हूँ, so c1 plus c2, so that is c1 k1 epsilon naught a, area for cross section is a by 2, right, for k1 and k2 each, c1 and c2 each, so it is a by 2, but distance is also half, d by 2, right? It is shown in the figure that it is d by 2. So distance is also half, so divide by d by 2. So d by 2 and this cancels, so I get k1 epsilon naught a by d plus k2 epsilon naught a by d. So in this I can take everything else as common, so it will become k1 plus k2 times epsilon naught a by d. And I am putting the same thing. So k1 plus k2 epsilon naught a by d. Now plus c3. What is c3? C3 is again just k, which is k3 epsilon naught a, area of cross section this time is complete, right, a, divide by d, distance is again d by 2, so that is d by 2. So this time it is 2k3 epsilon naught a by d, so divide by 2k3 epsilon naught a by d. Now d is there in every term, so cancel out kar do. Epsilon naught a is also there, cancel out, so you get 1 by k is saying ki, then the dielectric constant k is given by, so answer is 1 by k is given by, question में थोड़ा सा change है, 1 by k कर लो, तो then you will get this option, right, 1 by k1 plus k2 plus 1 by 2k3, that is the answer. So you'll get B if they are asking 1 by k, otherwise none will be the answer अगर k ही पूछा है. Is that clear everyone? Do I have said yes? 3. किसी को डाउट है तो just ask the doubt. Is there any doubt? हम लोगों ने कैपेसिटर्स इन पैरेलल एंड सीरीज यूज किया है, एंड वन मोर फॉर्मूला C is equal to K epsilon naught A by D. That's all. ठीक है. Moving to next question. Next question is two equal point charges fixed at x is equal to minus a and x is equal to a on the axis. Another point charge x is placed at the origin. The change in electric potential energy of Q when it is displaced by a small distance, small x. This x is very small distance along the x-axis is approximately proportional to. So basically question is saying ki on axis, see we have already kept a point charge over here, so that is capital Q, and there is one more, there are like two equal charges, so I'm assuming them to be small q and small q. They are kept at x is equal to minus a and x is equal to plus a. So on origin we have written, we have kept q. Now if we move this by x, then q comes over here. So I am writing, they are asking ki change in electric potential. So let us just shift it and then write the potential. Okay, and initially potential. So let's just write initial potential, final, and then we will find change in potential. So if we talk about initial potential, then I'm talking writing V initial. So that is KQ by R. So this distance initially is A. This distance is also A. So it is 2 KQ by like K potential energy. So that is K Q1 Q2 by R. So it is K Q by A, and it is like twice of that because there are just two charges. So this is initial potential energy. Let's just talk about final potential energy. So if we talk about final potential energy, U final, 1 second, I written V. It is not talking about potential, it is talking about potential energy. So this is initial potential energy, final. Final is K Q1 Q2 by R. So K Q by, distance between them now is A plus X, and potential energy due to other is K Q by A minus X. So let us first simplify this. So I am taking K Q common. It is 1 by A plus X minus 1 by A minus X. Now you take LCM, so it is A square minus X square, that is A plus B, A minus B, and A minus X minus A plus X. So A is cancelled and we get 2x, right? So change in potential energy is KQQ times minus 2x divided by A square minus X square. This is the final potential energy. What is the change? Delta U, change in potential energy, which we have to find कि किसके proportional में है. So change is final minus initial. And if you just do that, then what will we get? In both of these things, we can take common, right? 2kq. So I'm taking common 2kq small q by, okay, so this becomes final. Final is minus x by a square minus x square, and then minus initial, that is 1 by a. I have taken everything common. Now नीचे में just take LCM and solve it and then neglect the x when compared to a. So what do we get? 2kqq in bracket, it is a times a square minus x square. Now this is basically minus ax, then it is minus a square plus x cube, right? I'm writing it over here. So I'm just moving to next page. थोड़ा space मिल जाएगा. I'm clearing it all. So what we have written is 2kqq. In bracket it was 1 by minus x by, that was final, a square minus x square minus 1 by a, right? So after solving this, we get this a square minus x square, and here minus ax minus a square plus x square. Now here x is very small, so you can just neglect it. So this term and this term is neglected. Here this term is, wait. यहाँ पे नेग्लेक्ट नहीं होगा. Just a second. We have already written, it is change in potential energy. तो इसने लिखा है 1 by a 2kq. It has taken common 1 by a in this step. 1 by a minus a upon a square plus x square. Wait a second, हम लोगों का x आ रहा था. I think we have done some mistake. In initial energy, we will write k q. I'm talking about final potential energy when we move it by x. K q1 q2 by a plus x plus k q. It is plus, not minus, because both are positive charges, so it will add up, right? So we'll get upon a square minus x square, and here it will be a plus x plus a minus x. So you will get 2a over here. So we won't get x over here, we'll get a. And then you will get a square minus x square minus a square. So this is cancelled, and the left thing is x square. So here I am not neglecting in numerator, but in denominator you can neglect. So here you will get a cube, and here you will get x square. So we can say delta u is proportional to x square. Is that clear? हमने यहाँ पे mistake कर दिया था minus sign लेके. Both the charges are positive, so potential energy will add up, right? Is this clear? 3 have said yes. Doubt है किसी को भी? Okay, next question पे move on कर रहे हैं. We are moving on to next question. If you have doubt, please ask. अगर किसी को doubt है, you can just send a message to me. Now, next question is, wait, let me move to next question. Next question is a parallel plate capacitor. A parallel plate capacitor C with plates of unit area. So area of cross section is 1 meter square. So that is unit area. And separation D, which is shown in the figure, is filled with a liquid of dielectric constant K is equal to 2. K is equal to 2, it is given. And the level of liquid is D by 3 initially. Suppose the liquid level decreases at a constant speed v. So if liquid is filled in this region, which is d by 3, and it is also decreasing. Okay. Now he's saying ki write the time constant as a function of time t. So time constant, if we check the time constant, tau is equal to RC. Now C, you can say ki it is made up of two capacitors, one which is filled by dielectric constant K is equal to 2 and another which is empty, right? And both of them will be in parallel or series. They are in series like this. So let us consider them C1 and C2. I am calling this as C1 and the rest as C2. So equivalent capacitance I have to use, because this is a simple circuit in which only R and C are connected. So time constant is going to be R times C equivalent. C equivalent is overall this capacitance. So now let us just write ki C equivalent can be written as C1 C2 upon C1 plus C2. If we write in one word directly, otherwise you can write 1 by C is equal to 1 by C1 plus 1 by C2. In this, the thing is ki both are changing. Here this distance is changing and here this distance is also changing. So let us just take ki this distance is x. So this distance is d minus x because total is d. So C1 can be written as, if I write C1, then it is epsilon naught A by d. Area of cross section is same. D is d minus x. C2 if I take, then it is k. K epsilon naught A by d. D is just x. So let us just find the value of C equivalent, which is C1 C2 upon C1 plus C2. So if you do that, then what do we get? Here C1 into C2, so epsilon naught A by d minus x into K epsilon naught A upon x divide by addition of them. So epsilon naught A I am taking common, I get 1 by d minus x plus 1 by x. Now if I simplify this, epsilon naught A is gone. Now this denominator will also be simplified. So it is x plus d minus x. So x plus d minus x over d minus x into x. This is the denominator. And eventually this x is gone. So this thing will be gone with this, right? So what do you get? It as k epsilon naught A is left in numerator. This denominator is gone. And then divide by, only d remains in. Wait a second, some mistake is done. कुछ गड़बड़ किया है. Just 1 second. Yes, I forgot k. यहाँ पे k और आएगा, so that nothing will be cancelled. K is in k divided by x. I forgot this k. So this won't be cancelled out. Denominator will be, this will be cancelled out, but here it will be kx. So it is, I'm taking d plus x common, then in bracket it is 1 minus k. Is that clear? I forgot this k, so it is k by x. So this is x. This is x plus dk. K will also multiply with this. So dk plus x into 1 minus k. Now everything is clear. So next is, now this x is continuously changing. So if we put just this c value instead of here, then we are going to get our answer. So let me just clear a screen a little bit. So I'm going to write this value. थोड़ा सा neatly करते हैं. So it is R times this. So R K epsilon naught A times R. R is just resistance का value, divide by dk plus x into 1 minus k. Now what is x? So see, if we have a look on this, so we have assumed that this distance is x, right? So basically x is the distance after t time. Now originally it was, let's say, t by 3. It doesn't look like t by 3, but let's say originally it was t by 3. Then how much is this distance? This is vt because liquid is falling with a constant speed v. So it is v into t. So can I write d by 3 must be equals to x plus vt? Now from here x comes to be d by 3 minus vt. So if we substitute just that instead of x, we are going to get our answer, right? So time constant is k epsilon naught AR divide by, numerator I am writing separately. सो न्यूमरेटर को हम लोग अलग से सॉल्व कर लेते हैं. इट्स डी के प्लस एक्स विच इज डी बाई 3 माइनस वी टी टाइम्स 1 and d by 3 minus k will also be multiplied and with this and minus kvt. Now यहाँ पे कुछ चीजें सिंप्लीफाई हो रही है. dk minus dk by 3 that is 2 dk by 3. So this is 2 dk by 3 and this is d by 3 plus d by 3 and minus vt minus kvt. So minus vt times 1 plus k, right? Minus vt times 1 plus k. Now let's just put the value. A is 1, so this is not that, this can be neglected because area of cross section was 1 and k is also 2. So it is like 4d. It is 4d by 3 plus d by 3, that is 5d by 3. So I will get 5d by 3 minus vt into 2, that is 2vt. यहाँ पे LCM और ले लो तो 5d minus 6vt divide and 3 will go up, so it will become 3. So it will become 3k. K is 2. यहाँ पे भी we have to put 2, so that is 6 epsilon naught r divide by 5t minus 6vt, and that is tau का function, tau as a time. Is that an option? 6 epsilon r upon 5d plus 3vt. A is the answer. Is that clear? Any confusion? Let me re-explain कि क्या क्या किया है. हम लोग एकदम फास्ट में re-explain कर लेते हैं. So basically idea is that I have said कि capacitor C is equivalent of two capacitor. The reason is कि capacitance is continuously changing. Why capacitance is continuously changing? Because this liquid level is continuously changing. It is dropping with a constant rate v. Now this distance initially I have assumed it to be, let us say this is x and this is d minus x. Now I have considered this as C1 and this as C2. So equivalent capacitance is C1 C2 upon C1 plus C2. So that's what it is finding, equivalent capacitance, and then you put the value of each, and value for each is C1 is epsilon naught A by D, and D is in this case D minus X, and C2 is K epsilon naught A by D. D is X in this case. Once you put these values and simplify, you get this. Now this X can be written as, see, there is a relation. So suppose initially level was here. So I have said at any time, let's say it is X, right? So the distance traveled by the liquid is Vt in time t, and the initially total the level was d by 3. So I said X can be written as d by 3 minus Vt. So X can be written as d by 3 minus Vt, and you just multiply with R, so you get value. And then at the end, you just put A equals to 1 and K equals to 2, so you get this answer. Any confusion? Any confusion in this solution? किसी को भी कोई भी confusion है? अर्षा, अंकिता, अक्षिता, श्लोक, कौशल, any confusion? ठीक है. Let's move to the next problem. So, 1 second. Next problem is this question. So he's saying कि यहाँ पे 2 microfarad capacitor is charged as shown in the figure. So this is connected, S is connected to 1. Here S is connected to 1. Now he's saying the percentage of stored energy dissipated after the switch is turned into position 2. So when you turn it into position 2, what will happen? First capacitor, 2 microfarad capacitor will get charged. It will store some energy. Then when it is switched to position 2, some of its energy will go into 8 microfarad capacitor also. And जब energy का redistribution होता है, at the time some energy losses are there, right? उसका formula याद है किसी को? The energy lost is half C1 C2 upon C1 plus C2 whole square into whole square नहीं आएगा I think, into 1 minus V1 minus V2 whole square, that is potential changes from V1 to V2. दैट इज द एनर्जी लॉस। अगर किसी को फॉर्मूला याद है तो फास्ट हो जाएगा, अगर नहीं याद है तो टाइम लगेगा, ठीक है। सो 1 सेकेंड ना, पहले अज्यूम करते कि फॉर्मूला याद है एंड देन याद अज्यूम करेंगे कि फॉर्मूला जिसको नहीं आता वो उसको कितना टाइम लगेगा। सो पहले क्या होगा, सो इनिशियली अगर इफ आई टॉक की एनर्जी स्टोर्ड इनिशियली, आई एम टॉकिंग अबाउट इनिशियल एनर्जी दैट इज हाफ CV स्क्वायर, C इज 2, मैं सारा माइक्रोफेरेड में ही रख रहा हूँ C को, E को वोल्टेज में, एंड चार्ज अगर आया तो माइक्रोकूलम, सो हाफ CV स्क्वायर। तो बैटरी, पूरी बैटरी के अक्रॉस यही कनेक्टेड है, तो एंटायर इट विल बी चार्ज बाय अ पोटेंशियल ऑफ V, right? So half CV square, so that is V square. So initial potential energy is V square. Obviously this was microcoulomb, so this is microjoule. I am not going into units. हम लोग सारी चीजों को एक ही जैसा रखने वाले हैं. So there is, because percentage change निकालना है, right? The percent of the, तो जब हम percent निकालते हैं तो it is going to basically energy change divided by initial energy into 100. So initial energy and energy change that has to be in same unit. Now next is final energy निकालते हैं. So final energy निकालने की भी जरूरत नहीं है. We know how much is lost. तो if we apply directly the formula, तो ये वाला formula है कि loss का formula है. Just 1 second. This is energy which is lost or dissipated, which is basically energy goes. Okay, so यहाँ पे values रखना शुरू करो. Half C1 C2, that is, and this formula is not valid always. It is valid only if one charge capacitor जिसका initial voltage was V1 is connected to another capacitor of C2 and जिसके across कोई potential difference नहीं था and जिसके across potential difference was V2. That's all, है ना? तो याद रखना ये फॉर्मूला, काफी जगह काम आ जाता है डायरेक्टली. सो इसका डेरिवेशन भी करेंगे हम लोग. अगर किसी को फॉर्मूला याद नहीं है तो क्या करना है. सो हाफ C1 into CT, that is 2 into 8 divide by 2 plus 8, 10, and V1 minus V2. So V1 is V and V2 जो second capacitor है that was completely discharged initially, so minus 0 whole square. So this is V square and 2 cancel. This is basically 8 by 10 V square. Again this is in microjoule only. So what is percentage? Percentage is lost energy divided by initial energy into 100%. So you get 80%. Is that clear? डायरेक्ट आंसर आ गया. अब अगर किसी को फॉर्मूला नहीं याद है तो क्या क्या करना है, तो ये प्रॉब्लम काफी लंबा चला जाता है. अगर किसी को ये वाला फॉर्मूला नहीं याद है, ये वाला, तो इसके लिए हम लोग स्टार्ट करें. सो इनिशियल एनर्जी विल रिमेन एज इट इज, देन हमको चार्ज डिस्ट्रीब्यूशन करके वी हैव टू अगेन फाइंड द एनर्जी. सो लेट अस मेक द सर्किट वंस. सो इफ वी मेक द सर्किट, then see this is 2 microfarad which was connected to the battery. तो इधर से चार्ज आ रहा था. हाउ मच चार्ज विल कम? Q is equal to CV. So C is 2 and V is V. Again ये माइक्रोकूलम में चार्ज, तो यहाँ पे पॉजिटिव, यहाँ पे minus 2V. This is charge and it is connected to another capacitor जिसपे initially that is discharge. तो इस पे चार्ज है 0. अब यहाँ से क्या होगा कि चार्ज वापस डिस्ट्रीब्यूशन होना शुरू करेगा. So let's say there is Q charge. So there will be minus Q charge on this plate. There will be Q charge has been given, so charge will be 2V minus Q and charge will be 2V plus Q. This is 2 microfarad and this is 8 microfarad. But they will charge, the distribution of charge will stop once the potential difference across each is same. So Q is equal to CV, V is equal to Q by C. So I am just going to write Q1 by C1 is equal to Q2 by C2. तो इससे हमें small q की वैल्यू आ जाएगी. So once you write that Q1 by C1, that is 2V minus Q by C1, you always take positive charge only, higher potential वाला, है ना. So 2V minus Q by C1 that is 2 is equal to Q by C2 that is 8. तो इसको simplify करते हैं, ये 4 and that is 8V minus 4Q is equal to Q, so is equal to 5Q. तो यहाँ से Q की वैल्यू आ गई 8V by 5. तो अब हमारे पास चार्ज आ गया, इसके ऊपर 8V by 5 चार्ज है एंड इसके ऊपर चार्ज कितना है 2V minus Q. So 2V minus Q is 8V by 5. So that is 10V minus 8V, that is 2V by 5. तो 2V by 5 इसके ऊपर बचा और 8V by 5 इसके ऊपर चार्ज है. अब हर एक की एनर्जी निकाल के ऐड कर दो, you will get U final. So U final is half C1 V1 square plus half C2 V2 square या फिर Q square by 2C. That is better because अभी हमने Q निकाला है. So I am going to use Q square by 2C. तो पहले वाले की क्यू स्क्वायर दैट इज 2b बाय 5 का स्क्वायर बाय क्यू स्क्वायर बाय 2c, तो 2 into 2 that is 4. Again energy is in microjoule only, plus again q square by 2c, so that is 8v by 5 का square by 2c, so that is 16. कॉमन ले लो चीजें, तो यहाँ पे 25 कॉमन आ रहा है, ऊपर में 2v v स्क्वायर कॉमन है, 2b कॉमन आ जाएगा, तो 4v स्क्वायर ऊपर में कॉमन है, नीचे 25 और 4b, तो फर्स्ट टर्म में बच रहा है दैट इज 4v स्क्वायर ले लिया, बेसिकली एवरीथिंग हैज बीन टेकन, तो 1 प्लस सेकंड के अंदर 2b, तो 4 बचा, 4 का स्क्वायर 16 बचेगा इधर, और नीचे बचेगा 4 कॉमन लिया नीचे हमने, तो 4 और बचेगा, so that is 4, तो this is 5, 5 से पूरा 5 से ये 5 कैंसिल हो जाएगा, 4 से 4 कैंसिल, so it is v square by 5. Now if you just find the change, then it is 4v square by 5, right? The final minus initial, so this is lost, so energy which is lost is 4v square by 5 divided by initial, that is v square, and if you multiply into 100 to find percentage, you will get your answer as 80% वापस से. So the thing is कि फॉर्मूला याद है तो 1 मिनट भी नहीं लगा, फॉर्मूला नहीं याद है तो प्रॉपर्ली 3 to 5 मिनट्स लग जाएंगे. Is that clear? Any issue in this question? तो फॉर्मूला याद कर लो. 1 second. Is there any issue in this question? किसी को भी डाउट है, कुछ भी डाउट, जस्ट से. इज देयर एनी डाउट? ठीक है, आगे बढ़ते हैं. नेक्स्ट क्वेश्चन, लेट मी क्लियर द स्क्रीन फर्स्ट. दिस इज द सॉल्यूशन. सॉल्यूशन में भी उसने फॉर्मूला से ही किया है ना, सो इट इज ऑलवेज बेटर टू रिमेंबर द फॉर्मूला. नेक्स्ट क्वेश्चन इज, two identical thin rings, each of radius r meter, are coaxially placed at a distance capital R meter. So let me just make the figure. So there are two rings, there is an axis, and there are two rings which are placed coaxially on it. Both are having same radius. So these are two rings, and this is their axis. मैं इनके सेंटर दिखा रहा हूँ, just a second. So this is center of the first one, this is center of the second one, और दोनों की रेडियस r है, कैपिटल R है. If they are r distance apart, so this distance is, एक second, placed at a distance r meter apart. So let us take की रेडियस is small r, है ना. Now if q1, okay, radius is also capital R and distance is also capital R. Now if q1 coulomb and q2 coulombs, so these are respectively the charges uniformly spread on the two rings. तो इसके ऊपर चार्ज q1 है, इसके ऊपर चार्ज q2 है. The work done in moving charge small q from the center of one ring to the other is, तो यहाँ से इसको हम point A बोल देते हैं, इसको point B बोल देते हैं. So we have a small charge q which is moving from this point to this point, and he is asking work done. Work done का basic formula is q delta v. तो basically q तो पता ही है, हमें सिर्फ v at b निकालना है, delta is final minus initial. तो v at a निकालते हैं, v at b निकालते हैं, subtract करके q से multiply करते हैं, we'll get our answer. So अगर हम va निकालते हैं, so basically q is kept at this center of ring number 1. So पहला इसका center पे जो potential आता है, that is kq by r. Right, so q is q1 charge of ring by radius. Now second की वजह से जो potential आता है उसमें all the charges located at this distance, right, that is r square plus r square and square root. तो root to r के ऊपर पूरा charge q2 रखा हुआ है from point A. So potential is a scalar quantity, so kq by r, right. So q is q2 by distance is root to r. तो यहाँ से एक तो आ गया VA. VB अगर निकालते हैं, so when it reaches to B, then potential जो है वो आएगा KQ2 by R plus KQ1 by, अभी Q1 से डिस्टेंस हो जाएगा √2R, और इन दोनों को सब्ट्रैक्ट करना है. तो काफी चीजें हैं जो कॉमन ली जा सकती है, K by R and in fact this pattern also, एक second, this is basically q1 plus q2 by root 2. यहाँ पे भी आप कॉमन ले लो k by r and in the bracket it is q2 plus q1 by r, q1 by root 2, my bad. तो इनका डिफरेंस निकाल लो एंड देन जस्ट मल्टीप्लाई विद q. सो क्या आता है देखते हैं, इनका डिफरेंस निकालते तो आई विल गेट k by r will remain common and now I will get k is 1 upon 4 pi epsilon naught obviously and q1 minus q2 मिलेगा इधर एंड यहाँ पे मिलेगा q2 minus q1 by root 2. तो एक काम करते हैं, इसको माइनस बना देते हैं और इन दोनों के साइन स्विच करके q1 minus q2 कॉमन ले लेते हैं. So I am taking q1 minus k by r is already there, q1 minus q2 I am taking common. तो फर्स्ट वाले इन टर्म्स के अंदर 1 बच इज रिमेनिंग एंड इन दोनों के अंदर बेसिकली -1 by root 2 बच रहा है, दैट इज root 2 minus 1 by 2 root 2. So I am writing it again and just multiply with q, so you will get your answer. So it is q k को अपॉन k को हम लोग लिख रहे हैं 1 upon 4 pi epsilon naught और एप्सिलॉन है सारे ऑप्शंस के अंदर, so I am not going to use epsilon naught and k by r then q1 minus q2, so q then delta v में k by r into q1 minus q2 root 2 minus 1 divide by root 2. ऐसा कोई ऑप्शन है? 4 pi epsilon naught r root 2 minus 1 q1 plus q2, ये वाला गलत है. B is the answer. Is there any confusion? क्या क्या किया? Process has to be clear. They are asking work done is q delta v. So delta v is we just need to find potential change of difference in potential and that is एक एक जगह पे potential निकाल लो. तो that is a scalar quantity, तो दोनों रिंग की वजह से separately add up हो जाएगा, कोई vector addition नहीं करना है because it is a scalar quantity. Is that clear? आयुष को क्लियर है? Anyone else जिसको डाउट है कुछ? If you are having any doubt, please raise the hand. Next question पे move on करें. Okay, I am moving to next question. If you are having any doubt, you can ask. One second. So this is the solution and next question. Now next question is a charge q is fixed at a charge plus q is fixed at all the points x is equal to x naught, 3x naught, 5x naught and so on till infinity on x-axis, and a charge minus q is fixed at each of these alternate 2x naught, 4x naught, 6 naught, x naught. So एक बार diagram बना लेते हैं so that we get a clear idea. So this is my x-axis. So I have this is my x is equal to 0, that is origin. पहले x naught पर रखा हुआ है minus q, then 2x naught पे रखा हुआ है plus q, then again minus q, then plus q and so on. So that's how these charges are kept. Okay, and these distances are x naught each. Now question is saying take the electric potential at a point due to a charge q at a distance r from, this is misprint, r to be kq by r, right? That is a normal formula. kq by r हमें potential लेना है. Then the potential at the origin due to above system of the charge is. So what is the total potential at origin? तो हम लोग लिखना शुरू करें तो just kq by r, right? k पहले के लिए लिखेंगे तो हम लोग लिखेंगे minus q by x naught, सेकेंड के लिए it is plus q by 2x naught, थर्ड के लिए it is minus q by 3x naught, फोर्थ के लिए it is plus q by 4x naught and so on. Now it is kq by x naught I can take common, right? And then what remains here is, एक काम करो, वेट मैंने थोड़ा उल्टा ले लिया है, इन सब पे पॉजिटिव है और इन सब पे नेगेटिव है, माय बैड. जस्ट अ सेकेंड, मैं इन पे माइनस कर देता हूँ. आई हैव टेकन द अपोजिट वन. there is minus on these and positive on odd numbers. So basically ये सारे भी उल्टे हो जाएंगे. Just 1 second, let me change the sign. So it will become this minus plus this minus. Okay. किसी ने कमेंट किया है कुछ? आंसर इज ठीक है. एक सेकंड, किसने बताया आंसर? Yes, it's correct. Harsha, it's correct. So kq by x naught I have taken common. So you take 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus and so on. Still infinity. So basically this thing is what? So this thing is, यहाँ पे देखो, this thing is not going to be zero, right? Because each two term is giving us something, right? This is positive number, this is positive number. So this is not going to be zero. अब 1 भी नहीं आएगा because it is, this is positive. अच्छा 1 आ सकता है, ठीक है. इसके लिए हम लोग को इस सीरीज का एडिशन करना पड़ेगा. So इसके एडिशन के लिए टेलर सीरीज एक्सपांशन याद करना पड़ेगा of ln 1 plus x. एक्सपांशन ऑफ दिस इज, किसी को याद है? x plus x square by 2 factorial by 2 minus आएगा. एक सेकेंड, आई थिंक इट्स दिस. There are alternate plus minus. Minus plus x cube by 3 minus x 4 by 4 and so on. So if we just keep x is equal to 1, then this will become what we want, right? So this entire thing is ln 2. Is that clear? Is that clear? Expansion of ln 1 plus x is this. You just put x is equal to 1. This entire left hand side becomes the thing in bracket, and eventually we get our answer as ln 2. So it is kq by ln 2 x naught. Answer is D. एक सेकेंड, और किसी ने, यस, हर्षा ने करेक्ट आंसर दिया था. लेट्स मूव टू नेक्स्ट क्वेश्चन. 1 second, let me clear the screen. This is the solution. Now, next question. A parallel plate capacitor of plate area A and plate separation D is charged to potential difference V. Okay, so standard things are there. Distance is D, area is A, and it is charged to a potential difference of V. Now, and then battery is disconnected. Always remember, when battery is disconnected, no charge can come and go. And question is also about that only. Now, then a slab of dielectric constant. So basically this is a dielectric constant slab, and this is inserted between the plates of the capacitor, so as to fill the space between plates. If Q, E and W denotes respectively the magnitude of charge, the magnitude of electric field between the plates, and the work done on this system. W is the work done on this system, and is also saying after the slab is inserted. So basically this is Q is after, charge after, and E is electric field after. Okay, not initial one. And W is the work done on this system. In question, in the process inserting the slab, then incorrect options. We have to find incorrect options. So let us start ki kaise karte. So first is charge. As I told you, once battery is disconnected, see, there is always this confusion ki if battery is there, then if you insert a dielectric slab, then potential difference will be maintained by the battery by providing some additional charge. Okay, and if battery is disconnected, then basically charge on each plate will remain same and potential difference will change, because no charge can come and go, right, on these plates. So charge will remain same. So in our case, this is the second case. So charge will remain same, as no charge can go and come because there is no battery anymore, right? So our case, charge will remain same, and question is saying Q kitna hai. So he's asking us also Q. So let us say initially Q and minus Q was there. So I'll just write ki Q is equal to CV. Q is equal to C is epsilon naught A by D into V. So Q is this only. Q will remain this only, even if dielectric slab is inserted. So this option is correct. He's asking incorrect, so A is not the answer. Next is Q is equal to epsilon naught KAV by D. So this is definitely incorrect because first wala correct ho gaya. Next, electric field. Now the thing is कि as soon as you insert the dielectric slab, तो electric field का basic formula होता है V by D, right? So now V after the dielectric slab is inserted, distance remains same. तो V कितना हो जाएगा? So I am saying कि Q remains same. So I can write Q is equal to CV, which is V initial, C initial is equal to C dash V dash. Now V dash is basically C dash हमें अभी पता है C dash is K times C, right? And V dash is I don't know, so CV. So I from here I can find कि C cancel out हो जाएगा. V dash is V by K. So since V is V by K and D is D, so this is VK by D, and what is VK by D? आ गया, option भी आ गया. So this is the correct again. Now next is work done on this system. How much is work done on this system? तो हमने कितना work किया है? So we'll just find energy. So we'll find final energy, initial energy. If energy increases, then we are doing positive work. If energy decreases of the system, then we are doing negative work. So I am finding initial energy. Initial energy is half CV square. That is all initial things. Final energy is half C becomes K times C, right? अभी क्या था? It is KC because dielectric slab is inserted, and V square. So that is V dash square. अभी V dash find किया था. It is V by K. So it is V square. V dash square is V square by K square. 1K cancels out. In both the things, you can take half CV square common. It is 1 minus 1 by K. And what is C? Wait a second. This is initial and this is final. तो हमें करना है final minus initial. So this is minus 1 and plus. So 1 by K is less than 1 and this is greater than 1. And हमारे option में देखो, everything is else is same. This is half. C is epsilon naught A by D, original C, V square, 1 minus 1 by K. But this is not work done on the system. Work done on this system is negative. We are doing negative work. The reason is कि ये इसको automatically attract करता है. So we have to push it. Okay. So in the process, we are doing some negative work, but answer given is positive. So work done on the system has to be negative, not the positive one. So symbol की वजह से, if it is multi-correct, then you have to take D also. Is that clear? This is also incorrect. So option is BD. If it is single choice, then go for B only. Is there any doubt? Magnitude is given as correct, but this is negative. The overall answer is given as positive, but work done on this system is negative because we are doing some negative work. Is that clear? Harsha, Ayush, Ankita, all are clear. Teacher is done. ठीक है. Next question पे we are moving on. I'm clearing it. So a few electric field lines for a system of two charges Q1 and Q2 fixed at two different points on x-axis are shown in the figure. Now these lines suggest that. What does these lines suggest? Now, can you see there are 3, 3, 6 and 3, 9, 12 and 13. There are 13 field lines which are going out from Q1. So 13 lines and they are going out. And for Q2, there are 1, 2, 3, 4, 3, 3, 6, 7, 8, 9. So for Q2, there are 9 lines and they are going in. So if their lines are going out, means it is a positive charge. Lines are going in, that implies that it is a negative charge. More lines means it is more in magnitude. So Q1, magnitude of Q1 is greater than magnitude of Q2. If this option was also there, Q1 is greater than Q2, that is also correct, right? So option A is correct. Option B is incorrect. Now option C, at a finite distance. So let us, this is Q1. This is Q2. Obviously, this is negative charge. I am not writing minus Q2. That is just implying that this is a minus charge. And this is like more positive charge. Now, at a finite distance to the left of Q1, left of Q1 means over here, the electric field is 0. From positive it is going to be away, from negative it is going to be towards, and the thing is ki this one is going to be more because it is KQ by R. So K Q1 by, let's say this distance is R1 and this distance is R2. So electric field produced by Q1 will be more. Reason is कि उसका distance भी कम है, that is inversely proportional and charge is more. So field can't be 0 at any of this point. Now second is at a finite distance to right of Q2. Here the field is going to be 0. That answer is correct. Reason is कि इसकी वजह से इधर होगा, Q2 Q1 की वजह से away होगा. But the thing is कि Q1 is more, but distance is also more, right? Q2 is less, but distance is also less. So they can be balanced at some point. In such a manner, जो हम लोगों ने already ऐसे type के question किए होते हैं, KQ2 by, let's say this is, I'm calling this distance A and this distance B. So KQ2 by A is equal to KQ1 by B. Once this equation is balanced, then that will be the point value of A and B where it is balanced, right? So option D is also correct. Answer is AD. किसी ने answer भेजा है? Yes, Ayush, it's correct answer. Answer is AD. Any confusion in this part? See, number of magnetic electric field lines can't be tell exact value, but they can definitely tell ki if Q2 is 9x in magnitude, then Q1 is 13x. So we can always relate the strength of magnetic field basically by the charge. Is that clear? Number of field lines represent the charge of magnitude of the charge. More the charge, more number of field lines will be going out or going in. If they are going out, it's positive. If they are going in, it's negative. Next question. Okay. This question says, the diagram shows part of an evacuated tube in which a stream of electrons from an electron gun passes between a pair of parallel large deflecting plates. So basically these are two deflecting plates. So deflecting plates, the vertical displacement of electron beam as it leaves the parallel plates is x. So this is the vertical displacement when it just leaves. Now do not consider gravity, and the electron enters the deflecting region parallel to plates. So they are always entering parallel to this. Now which one of A to D below will change the displacement x of the beam as it leaves the parallel plate? तो क्या करने से displacement x change होगा, with either increases or decreases. Now first is increasing the accelerating voltage. Now accelerating voltage is this accelerating voltage. So if you increase this, electron will enter faster, right? So they need some certain time to do this displacement. Why they are doing this displacement? Because there is capacitor, so ये positive plate है, negative plate है, that's why electrons are moving towards that. And force on, there is a force which is there in upward direction, that is Q. Force is QE, that is E, charge on electron times electric field. Now the thing is ki we are not changing this. So we are not changing force, we are not changing mass, so we are not changing vertical acceleration. Now this x is nothing but x is what? X is equal to half AD square, that's all. U is 0. There is no vertical initial velocity. So vertical displacement can be written as just x is equal to half acceleration, which is E by m. E is the electric field which is inside the plates, into t square. T is the time in which they are remaining inside the parallel plates region. So I am saying ki faster they will travel due to this accelerating voltage. If you accelerate it, then they will leave the electron gun more faster, and eventually what will happen? Velocity will be more. If velocity is more, the time for which they are inside this region will be less, and x will also be less. So answer A is yes, A will change x. Now second is increasing the deflecting voltage. Now this is deflecting voltage, so that is like plus V and minus V. Now if you increase it, let's say you just increase it, then if you increase, then this electric field is going to increase, because electric field is nothing but VD, right? Ek second, V by D. Is that clear? So you change this, E is going to change, E is going to change, it is going to increase the X. So there is a change in X. Is that clear? So this is also going to change. Now third option is increasing the distance between electron gun and the deflecting plates. He's talking about this distance. If you increase this, then what will happen? Whatever the velocity with which electrons are leaving the electron gun, that will be the velocity of entering. So it doesn't matter. This time is also time for which electrons are between the parallel plates. So that won't change it. So option C is incorrect. It won't change X. Next is option D, increasing the distance between the two deflecting plates. So if you just increase this distance, keeping the deflecting voltage same. So changing the distance will change the electric field, and change the electric field will change the X. Is that clear? So option A, B and D are correct. Is that clear? This was a simple question. Sometime they might ask you to ask for definition also. And here T is nothing but C. If this length is L, then L is given by Vt. V is the velocity with which they are entering it. If they want to make it more complex, then they can give the potential difference of X. They can give exciting voltage also. So you can just write QV, that is EV, is equal to half mv square. Using this, like this is velocity and this is voltage, accelerating voltage. So using this, you have to find V, then using L, you have to find T, and using T, you have to find X. Is that clear? They might ask, they very well might ask a complex question like this. Any confusion? Anyone? We are moving to next question. Next is, a particle of mass 2 kg, charge 1 millicoulomb is projected vertically with a distance, vertically with a velocity 10 meter per second. Now this is projected vertically with 10 meter per second. There is a uniform horizontal electric field, and this is a particle of mass, and there is a charge also. So due to this charge, there will be a force in horizontal direction. And this is positive charge, and considering E is in this direction. So there will be a force QE. So due to this force, it will go in this direction also, right? So, and due to gravity, it will goes up and comes back, right? Now he's saying there is a uniform electric field of 10 raised to power 4 Newton per Coulomb. So this E is 10 raised to power 4 Newton per Coulomb. And let us just find this force only. So force is QE. Q is 1 millicoulomb. And E is 10 raised to power 4. Answer is 10 Newton. So this force is 10 Newton. Mass is 2 kg. So here in this direction, there is an acceleration of 5 meter per second square, F by M. And in this direction, there is acceleration due to gravity 10 meter per second square. Now, if generally this is too much, then we can neglect gravity also. But here we can't neglect it. Now, they are asking some certain questions: the horizontal range, the time of flight, the maximum height, the horizontal range. So, what will be the path of this? Now, path of this will be, see, it will go up and come down, and it will do accelerated motion in this direction. So, eventually it will be something like this. But the thing is, time of flight and maximum height will be defined by vertical components also. So just find it, time of flight, it is 2u by g. Just for a particle throwing in vertical upward direction, it is 2u sine theta by g, but sine theta is again 90. So 2u by g, it is 2, u is 10, and g is also 10. It is 2 seconds. So this is correct option. Now second option is maximum height. Maximum height ka formula is u square by 2g. Again, sine theta is 90, sine 90. It is not projected at some angle. तो वहां से u के कंपोनेंट करते हैं, वहां से एंगल आता है ना, sin theta or cos theta. So u square, that is 10 square 100 divided by 2 into 10. So that is 5 meter. So this is also correct. Now horizontal range. So option A and D. So for horizontal range, we have accelerated motion. So for, it is in the air for 2 seconds, right? And it is traveling in this direction. Initial velocity in this direction was 0, and acceleration in this direction is 5 meter per second square. So you just write S is equal to ut plus half it square. So 0t plus half, acceleration is 5, and t square, that is 2 square, so 4. So that is just 10 meter. So it will travel 10 meter distance when, like, before the time it comes back to the ground. So that is the range. So answer is 10 meter. This option is incorrect. So answer is A, B and C. Any confusion? Is there any confusion? किसी को कोई भी confusion है? Ask all the doubts from the questions which we have done, and then like I am ending the class. Is there any confusion? Please ask. Otherwise we'll end the class. No. ठीक है. Okay. Then all are saying no except 2. So let's just end the class. Bye bye. Take care.